Microbial is our microservices toolkit that we're developing fairly heavily at the moment. It's not a framework. It's definitely not a framework. It's a toolkit, not a framework. And it's just to help us with all of that kind of communication over Kafka. So, what does it do? It sets and retrieves system configuration for Zookeeper, transparently handles the Kafka offset management, provides us a simple microservice type API. It handles all the pattern matching and system execution, and gives us that simple API for construction. So let me just run through the execution pattern that we would use. So a producer, something that's requiring service, something that wants to get a job done, will typically round robin into across partitions on a request topic of some kind. Those requests will be picked up by the service instances, and any services that match the specific pattern that's been put in will execute. When the producer is putting its messages into the bus, it puts a return address in there. So it says the topic and partition that it wants its response on, if it wants a response at all. Any services that then pick up those messages and execute them will place the results back on the response topic based on the return address that's been placed into the bus, and that will be picked up by the producer. It's not a one-shot deal. These services can then call further services, and you can chain that execution. So we have a simple. It's just explaining what I just said there. So we have a very simple configuration setup. This is what will be stored in Zookeeper by Microbial. It says that we've got a request topic. It's using queuing semantics, 3 partitions, and to post them out in a round robin fashion. So just go across the partitions, and then we're also defining a response queue that's got 2 partitions, and that's just direct. And then we're just naming the brokers. The root broker, actually, we only need to name a single broker here, because the Kafka can go and figure out what the rest of the brokers are using metadata requests. So here's an example producer using Microbial. We give it a set of options. We need to tell it how to find Zookeeper to get the full configuration, and then we need to require in Microbial and give it those options. Once we've called setup, we're good to go. We're now running a register and giving it the topic name and telling it it's a response channel. And from then on, I'm posting requests at an interval of 1 second, and that's the actual request that's going in. So this is the JSON that's actually going across the bus, which is say something. It's a say request. So the corresponding microservice is I'm requiring in Microbial again here with the same set of options. This is a microservice that has 3 entry points, for example, and I just call the run function. I tell it to listen on the request topic, and I give it the consumer group of hello. And in this instance, I'm matching, when I get a request say, I want to match to this whatever function. When I get a request say with a more specific pattern of hello, then I execute the hello function. And then when I get a rumble request, then I execute the delegate function. And this delegate function here is interesting because it's actually making another request. So it's placing this request, when this service executes, it places this request on the bus, waits for a response, and then responds back to the original requester. So it's chaining those services together. Because that producer you just saw is just putting this onto the bus, it's least specific, so this function will match and execute. If it had put a pattern like that on, this function will execute. So it's all about putting those JSON patterns on and pattern matching to execute services. Does that make sense? Those code examples? So as I said, that's a quick tour of what we're doing in microservices and specifically how we're using Kafka to put our services together on projects. We're using that, there's 2 live projects right now that those are being used on. that are under development, and we have a few more coming on stream shortly. So we're learning a lot about these types of systems as we go on and actively develop them for our clients.
Are you the only people taking that project out of LinkedIn and using it in wider contexts, or is it?
No, it's being used a lot. A lot of people using it. A lot of very different use cases, but there's quite a lot of interest in adopting it for this kind of microservice.
Is there a style of application domain where you're finding the most interest?
Say this again?
Is there a style of problem that is most attractive to that architecture?
I think it's really where you've got where there's a lot of work happening on the back end, right? For a standard kind of dynamic web site, which is just linking to a database. It's not, you don't necessarily want to take this approach. But as you scale up and you've got more things going on in the back end, so you've actually got a lot of data processing going on. So because of one system we have right now, there's a lot of external APIs that are being called. There's about 10 different API providers, all varying different endpoints and different processing that needs to occur based on initial stimuli into the system. It's ideal for that because you can break those down into small units and compose them using this type of pattern. So it works very well in that context. So I think once you get beyond a certain point of actually having to do data manipulation and processing on the back end, it starts to make sense. Where you're not doing a lot, it's not worth the while.
So the most spectacular software failure in the last 12 months was Obamacare.
Yep.
Your system would have been perfect for Obamacare.
Absolutely.
Because it was all about APIs, just tons of them not incorporated.
Should have given us the gig.
They should have been. And they were using Backbone and Node.
Yep.
But not microservice.
Right. So I guess that's the key thing, is having that organisational structure in place. And for us, as we develop these kind of larger systems, the organisation you get from adopting this kind of structure is very valuable. Okay, that's me. I'm done, guys. So anyone wants to throw anything or code abuse?
Here.
Yo. I knew you would know. I knew you would disappoint me.
I'm just wondering, like, with all these separate processes, is there more of a high operational cost involved in managing all those processes?
Yeah.
What kind of scale do you have in the project?
So we're using Docker, like I said. So I think that gives you a lot of control over that. Without using containers, it would be more difficult. But if you're containerizing, then your front-end instance, your instances you're deploying to, the AMI image, I'm talking specifically about Amazon here, need only have the Docker runtime on it. You don't need to configure a whole bunch of other crap on there, right? Because that's all living in the container. So that makes it infinitely more manageable, because if you're scaling, then you just pull up a couple more of those instances and deploy your services onto them. And that can all be done, you don't have to program manually going and doing that kind of tools.
So all your services are up to this one Docker container on an instance?
Correct. One Docker, so one base image, spin up as many of those as you want. That's got the Docker runtime on it. Deploy your containers, depending on you'll then put some substructure on that, right? So you'll have pools of services on these files.
So I would group my services, say, particular.
It depends. Exactly.
Into one container.
Correct. No, sorry. Independent containers per service, but you might run those sets of containers in a logical grouping. Do you know what I mean?
Containers are low, are they?
Very low overhead. Yeah. You can, because they're just almost like a process. It's not like a virtual machine.
Right.
So it's LXC containers are very lightweight.
So your microservice instances are each of those things is contained in a Docker container.
Correct. Yeah. So it's they're very lightweight.
What kind of numbers on the services you have in the projects you've done? Are you into the hundreds?
We're not quite in the hundreds yet. No, in the kind of 30, 40 type area right now, but growing. So, and I would anticipate on those projects that as they evolve over time, the number of services will increase, but we'll have the structure there to allow that to happen, rather than having to approach it using more traditional ones.
What's the average number of lines code per service work out at?
I haven't got those numbers. I'd say
Hundreds?
it's in the hundreds. It's not hard set at 100. It's probably a little more than that. It'd be interesting to actually find out what those numbers are. See what the actual
It's not
lines are.
thousands though.
No. If it's thousands, you're going wrong. You're doing too much.
And in all of these services, well, you're always going to have that header on connected to your message.
Yes. In that answer. But again, like I said, not everyone does it that way.
Yeah.
Some people
You're
just
always going
doing
to have that connectivity to your.
You need some kind. Yeah.
Of course.
Absolutely. Yeah.
And where do you kind of decide the breakdown between what becomes a service? Does one thing, does it well?
Yeah.
Sometimes that one thing would have 2 or 3 different parts or different stuff.
Right.
Do you,
That's
it's just a matter of factor and kind
It's
of
down to you as a. But I guess the key point is that it doesn't. If you do it wrong, you can replace it. That's the point, right? So if you implement it initially and you deploy it, and then you think you're doing too much in one service, so break it into 2 and deploy those instead. That's the kind of idea behind it. Cool.
Is Kafka supported across multiple languages?
Yes, because it's I mean to access it you've got that TCP-based protocol. So as long as you've got the client libraries or the APIs to connect into it, then yes it is. And there are clients for most major languages. Yeah, I mean Kafka is actually written in Scala, so it runs on the JVM. But I think the project itself provides Java libraries. But there's definitely Ruby, Python, or kind of major languages.
Something similar using Vanish.
You could do something similar with Rabbit, yeah. Or ZeroMQ or whatever. We just prefer Kafka because of the kind of commit log functionality and all that stuff. You know, it's not bad.
Do you approach your services as just a single file, write it, run it a process, or do you package it as a module?
Usually it's a single file or a single set of files, but equally you could do it as a module. For sure. Not prescriptive.
Okay, that's great guys. Thanks for Peter for